been fascinated by the moon. At one time, he thought the moon was really a beautiful goddess who could bring him good luck. Today, space exploration has revealed many of the moon's mysteries. Astronauts have walked on the moon's powdery surface, exploring its dry plains and giant craters. But before man could ever reach the moon, he had to study the information that scientists had gathered over the centuries. We know that the moon is the Earth's closest neighbor, about 239,000 miles away from the center of the Earth. But where did the moon come from? The moon is the Earth's natural satellite. Many scientists think that the moon, the sun, and all the planets were born from the same whirling cloud of gas and dust. Our moon revolves around the Earth in its own orbit or path. And it stays in the same orbit because it is attracted by the force of Earth's gravity. Without the strong pull of gravity, the moon would sail away into space. Just as the Earth's gravity keeps the moon in its orbit, the gravity of the sun keeps all the planets in their orbits. Isaac Newton, the 17th century scientist, was the first to explain the pull of gravity. He said that the planets stay in their orbits because their speed is just fast enough to keep them from crashing into the sun, but not fast enough for them to fly out into space. The moon has its own gravity too, and its pull on the Earth helps cause ocean tides. As the moon travels from west to east, it pulls on the oceans like a giant magnet, causing high and low tides. At the beach, it's easy to see the difference between high and low tide. At low tide, the water has been pulled away from the shore. High tide is a good time for swimming. The moon's pull has drawn the water high up onto the beach. Telescopes are valuable instruments that help scientists learn more about distant stars and planets. Galileo was one of the first to use a telescope in the early 1600s. The telescope has told us much about the moon's surface. Its powerful eye reveals deep craters in the moon's surface. Many scientists think that these craters were caused by huge meteorites that came whizzing through space toward the moon. When they crashed into the moon's crust, they left deep holes. Through a telescope, craters look like dark, circular shapes. Some scientists believe that intense heat inside the moon caused volcanoes. These eruptions may have formed some of the smaller craters on the moon. The large dusty plains on the moon's surface are called seas because early astronomers thought these dark-looking regions were vast bodies of water. Towering mountain ranges cross the face of the moon. Some are higher than 25,000 feet. And mountains of 18,000 feet are not unusual. A dramatic canyon called Hadley Rill plunges 1,000 feet beneath the moon's surface. Bright rays seem to shoot out from many lunar craters, crisscrossing the moon's surface with light-colored streaks. Like our planet Earth, the moon gets its light from the sun. But unlike the Earth, the moon has no air and no weather. You couldn't breathe on the moon unless you brought your own air from the Earth. You couldn't hear any sounds because the moon's atmosphere is too thin to carry sound waves. And without a spacesuit, you could never survive the extreme temperatures on the moon. There are no clouds and no protective atmosphere to absorb the powerful rays of the sun. Heat scorches the moon's surface during the day and temperatures soar. At night, this tremendous heat quickly leaves the moon, and temperatures drop to about 270 degrees below zero. The moon, like the planets, has no light of its own, but reflects light from the sun. While the moon orbits the Earth at 2,300 miles per hour, the Earth and moon together revolve around the sun. With both the Earth and the moon in constant orbit, we sometimes have an eclipse. There are two different types of eclipses. In a lunar eclipse, the Earth moves between the moon and the sun, blocking the sun's light. The moon, covered by the Earth's shadow, grows dark. During a solar eclipse, the moon moves into position between the sun and the Earth, casting its shadow over part of the Earth's surface. Suddenly, the Earth grows dark. Birds stop singing and fly to their nests, thinking it is nighttime. The animal world is silent until the Earth moves out of the moon's shadow and daylight returns. From the Earth, you can see only one side of the moon. If you watch the moon for several nights in a row, you'll see that its shape seems to change. Some nights, you can see nearly all of the moon's surface as it lights the sky. Other nights, you can hardly see any of the moon's light. This happens when the side of the moon that faces us receives no light from the sun. If you keep watching the sky for several weeks, you will see the moon's lighted surface growing and changing as it receives more light from the sun. First, you see a slim crescent. Then, as the moon continues its journey around the Earth, you can see more and more of its surface. Finally, the sun shines on the whole surface of the moon that faces us. This is what we call a full moon. It takes about 4 weeks for the moon to travel through all its changes, or phases. It grows from new moon to full moon, and the same process repeats itself month after month. Long ago, people used the phases of the moon to measure time. Since the moon always takes about 30 days to orbit the Earth, it was a pretty accurate clock. Today, we still recognize the meaning of the moon's phases. Our word month comes from the word moon. When we turn a page on the calendar, we can expect to see a new phase of the moon. Man has long dreamed of being able to learn about the moon firsthand. In 1966, a Russian spacecraft made the first soft landing on the moon. In later space missions, American spacecraft equipped with cameras photographed the moon's rugged surface. These space missions set the stage for man's greatest adventure, a trip to explore the moon's ancient craters and valleys. For centuries, men had dreamed of a voyage to the moon. Man's giant step into space came on July 20th, 1969, when 2 American astronauts touched down on the Sea of Tranquility, a broad, lava-filled plain. Astronauts Neil Armstrong and Edwin Aldrin climbed down the ladder of their lunar module and began to conduct experiments on the moon's surface. One of their most important jobs was to collect samples of moon rocks for scientists on Earth to study. Rock samples older than 4 billion years were found on the moon. astronauts on all the Apollo space flights wore special spacesuits to protect them from the burning rays of the sun and to supply them with life-giving oxygen. In the almost weightless atmosphere, Earthmen moved about easily. On the moon, an astronaut could jump 6 times higher than he could on Earth. From their landing sites on the moon, Apollo astronauts could see the Earth spinning silently out in space. Soon they would be journeying back to their home planet, bringing with them new knowledge that would help us to better understand our world.